Welcome back to For the Mariners by the Mariners channel. The survival of a ship exhaust gas system depends on a delicate balance of temperature and chemistry, because the very fuel that powers the vessel contains elements that can destroy steel from the within. One of the most significant threats to the structural integrity of funnels, economizers, and scrubbers is low-temperature corrosion caused by reaching the acid dew point. Most marine fuels contain sulfur, which during the combustion process reacts with oxygen to form sulfur dioxide and a smaller portion of sulfur trioxide. As these exhaust gases travel through the system and lose heat, they eventually reach a temperature where the sulfur trioxide reacts with water vapor to form sulfuric acid. This specific temperature is known as the acid dew point. If the metal surfaces of the exhaust ducting or the heat exchanger tubes fall below this temperature, the sulfuric acid will condense from a gas into a highly corrosive liquid. This liquid acid rapidly attacks the carbon steel surfaces, leading to severe pitting, thinning, and eventual structural failure. The design of modern marine exhaust systems must therefore ensure that the gas temperature remains safely above this threshold throughout the entire flow path. Engineers typically aim to keep the exhaust gas at least 20 degrees Celsius above the calculated dew point to provide a safety margin against varying engine loads. However, this creates a conflict with energy efficiency because recovering more heat from the exhaust to produce steam or hot water means lowering the gas temperature further. To solve this, designers often use specialized materials like stainless steel or corten steel in the colder sections of the economizer, which have a higher resistance to acid attack. Operationally, the risk is highest during low load periods or when starting and stopping the engine because the exhaust volume and temperature are at their lowest. Troubleshooting corrosion issues in these systems involves regular visual inspections for signs of white or yellowish deposits, which are often indicators of sulfate formation. If you notice a sudden increase in the pressure drop across the exhaust gas boiler, it may be due to the accumulation of corrosion products and soot which stick to the wet acidic surfaces of the tubes. Maintaining the correct feed water temperature in the economizer is a vital control method to ensure the tube skin temperature does not drop below the condensation point. If the incoming water is too cold, it will chill the exhaust gas locally and trigger acid formation. Modern ships also utilize automated temperature monitoring systems that can bypass sections of the heat exchanger or reduce the cooling flow if the gas temperature drops too close to the danger zone. If you found this video helpful, please give us a thumbs up, hit the notification bell, comment, like, share, and subscribe for more insights. Thank you.